Good morning, students. We are already discussed about vibration method. In that, vibro compaction is discussed, that is blasting as well as vibroflow. Next method is vibro displacement compaction. In this, very important methods are there. One is displacement piles. Another one is also called as vibroflotation. So first we discuss today about vibroflotation. Vibroflotation is developed by Russian peoples, which is very famous method. In mid 30s, German peoples are using. Nowadays, American peoples are most commonly using. Why I am mentioning American people? Because it is the most advanced as well as it is densifying, great densification of soil. And this method is suitable for soil, sands as well as gravels with less than 20% silt or 10% of clay. So means this vibrofloat is specially suitable for sands and gravels. Carefully listen. Sands and gravels it is suitable, but condition is there, that is which with less than 20% of silt or 10% of clay. If it is clay is more than 10%, then it is not suitable. If silt is more than 20% is there, then it is not suitable for gravel or sand. Understood? Next thing, vibroflotation means, that is vibrofloat. Vibrofloat is a device generating vibratory force by rotating masses. So this has three processes in this case, vibroflotation. One is at the bottom as well as top, there is a water jetting action. Another thing is rotation, and third thing is vibration. So simultaneous three processes will be taking place so that the soil can be densified very quickly. Right? So properly listen. I will tell the this process how it is done. It is first I will tell the dimensions of this one. It is 432 mm in diameter, 1.8 meter long, 17.8 kilonewton weight, and vibrates at 1800 rpm frequency to develop a horizontal centrifugal force of 90 kilonewton. Means these are the dimensions which is shows the its capacity. Some units have a device to control the vibration frequency. Its top end has a water supply at the rate. See, observe here. Its top end has a water supply at the rate of 225 to 300 liter per minute under a pressure of 430 to 580 kPa. When you put this vibrofloat on the ground surface, first you start a water jet. The water jet has a water pressure. So usually that water will be at the rate of 225 to 300 liters per minute. It jets 225 to 300 liters at a pressure of what? At a pressure of 430 to 580 kPa. See, that's why the soil can be very quickly loosened, as well as your vibrofloat can be easily move with vibration. So densification will be very strong. So next thing, water outlets at the top and bottom end transfer water pressure to the soil to cause excess pore water pressure, leading to artificial soil liquefaction. This is very important. Artificial soil liquefaction means that is also densification of the soil around the vibrofloat and makes it sink to the ground at the rate of 1 to 2 meter per minute. Means if you have a water jet of 225 to 300 liters per minute, it will generate. Then this vibrofloat will move into the ground 1 to 2 meter per minute. Vibrations together with liquefaction leads to excellent densification of soil on reaching a depth of 2 to 3b, means we will stop at 2 to 3b. B here, B is width of foundation, you are already know it, right? So it is fulled out. Once it reaches 2 to 3b, it is fulled out at a rate of 0.3 meter per minute. Created formed around Vibrofloat is filled with local soil. Once you remove it, then you fill the local soil or other fill material. About 10% of volume of soil is compacted continuously, right? So then what are the advantages of using this Vibroflotation? So first thing, depending upon the type of soil, in a work shift of 8 hours, about 7,500 to 15,000 cubic meters of soil may be densified. See, observe here, if you work for shift of 8 hours, the soil densification will be about 7,500 to 15,000 cubic meters of soil will be densified. First thing. Second, usually the center to center spacing of this probe will be 1 to 5 meter, depending on the density of the soil desired. And also the bearing capacity of 250 to 4 kPa can be obtained from this method. See, usually this bearing capacity is very useful for the design. So if you use this method, so you can achieve up to 250 to 400 kPa can be obtained from this method. So this is regarding Vibroflotation. Are you understood? So next method is called as displacement piles. So usually displacement piles are nothing but it is also process like a compaction piles. In compaction piles, what we do, we will insert a pile and we densify the surrounding soil. Same thing in displacement piles also. In displacement, natural soils at a greater depth below ground level cannot be compacted layer by layer. So that is main important thing is, so in depth wise, usually at shallow depth you can compact the soil layer by layer, but for a greater depths, layer by layer compaction is very difficult for greater depths. So that's why this vibratory pile driving to cause a lateral soil displacement up to a desired depth and fill the voids, thus will helps for densification. So what this displacement pile do is, it will displace the soil so that the due to the vibration, so there is a densification of soil takes place. Vibration of soil adjoining pile, that is hollow pipe, usually due to impact type of driving, also leads to soil densification. However, a typical vibratory pile driver has a facility to control the frequency of vibration to match with the fundamental frequency of the soil pile system, to reduce the effort of pile driving and to optimize densification of adjoining soil. So what is the process in displacement? Well, I will tell you. So process of this driving of compaction pipe, that is the displacement pipe. A hollow casing pipe, first I will do is what we do is, a hollow casing pipe. Hollow means it is opened at both ends. A hollow circular casing pipe with a shoe is placed on a ground and driven down by vibration up to a desired depth, means whatever depth you require, say 8 meters, say 10 meters, 20 meters, whatever desired depth, up to that it is driven down by vibration. So what it does means, driven down with vibration means this vibration helps the surrounding soil to densify. So that is the advantage of this displacement pile. So here frequency is adjusted suitably to take advantage of fundamental mode of ground vibration. soil is placed inside the pipe, that is whatever hollow pipe you are inserted in, that soil is placed inside the pipe before it is withdrawn for reuse. Means once you complete that vibration process, that densification of soil, this hollow pipe again you can remove it and reuse for other works, other method, other places also. Other aspects of this method are similar to, means other aspects will be similar to as your compaction. You are already studied about compaction, but this is same as compaction. So it is nothing but here we driven this at hollow pipe with vibration. So this vibration helps displacement of the displacement of the soil. So displacement also help for densification. So what happens, due to the vibration, the surrounding soil is particles are rearranged and densification of the soil takes place. So that is regarding vibro displacement, that is displacement piles. So thank you.